Yes, yes, ma'am.
So I'll start the session.
Sure.
Okay. Good evening, everyone. A warm welcome to all the participants joining us online for the fifth day of Atal FTP on sustainable urban waste management, combining centralized, decentralized systems with AI innovation. We are delighted to have each one of you here. We have two sessions lined up for today. The first session is on emerging trends in urban solid waste management from Smart Monitoring to Circular Economy by Dr. Amarpreet Singh Arora, PhD postdoctoral research professor, Sankhayan University. He has PhD in environmental science and engineering, currently working as research professor, Sankhayan University, South Korea. He is working on NRF project, Smart Integrated Urban Climate Resiliency and Sustainability Assessment Planning System for Urban Regeneration and Building Renovation. He has more than 15 years of industrial and academic years of professional experience. He served as research scientist and global project manager, state Engg, South Korea, postdoctoral research associate, Yeonam University, South Korea. His research and technical expertise includes environmental bioengineering, smart urban systems, wastewater treatment. He has got his credit 22 peer-reviewed journal papers, four book chapters, and 16 conference papers. We are virtually fortunate to have you, sir, today. With immense pleasure, I welcome you, sir, to the session. Over to you, sir.
Thank you so much, ma'am, for giving this introduction. So, yeah, without wasting the time, so I'll begin my presentation. Ma'am, please let me know if you can see my presentation.
Yes, sir, the slide is visible.
Okay, thank you so much. Good evening, all the participants. And I'd like to initially thank the organizers for arranging this wonderful FTP. So for today's topic, I'll be focusing on the emerging trends in urban solid waste management from smart monitoring to circular economy. So right now you must have all discussed how important this subject is about waste management. So how it's being happening and carried out in some of the cases where I have myself in hand experienced those waste management practices, I will be sharing with you during my presentation. So during the presentation, there might be some questions which might arise in your mind. So you can kindly note it down or put it in the chat box. So at the end of the presentation, if we have sufficient time, we'll be taking up all the questions one by one. Yeah, so what we are going to cover in today's session. So first and foremost, I'll be giving you the brief introduction about what's the global urban waste challenge we have in our hands, and we need to understand the scale of the problem and the urgency which is needed at the moment. Then we move on to the understanding the paradigm shift, wherein right now still there are lots of developing countries which are kind of like focusing on the linear management of the waste, but they have to now actually focus on the circular side of the things. So how we can use and conceptualize the waste as a resource is very much important. Then the focus will shift during the presentation to understanding what are the smart monitoring and digitalization activities which are available, which can kind of like help us to revolutionize how we collect the waste and how we process them. And fourthly, the most important also is the policy and economic aspect of it. So we need to understand how the government policies and the overall policies needs to be shaped in so as to incentivize the responsible behavior of the people who are living in those cities. I'll be discussing two case studies after that. So one is South Korea case study. I am currently living in South Korea and it's been like 7 years. So I have experienced on hand how the waste is being managed. And of course, Japan is kind of like a sister city to South Korea. So it's quite nearby. I have been twice to Japan as well. So I'll be sharing what they are practicing in terms of waste management. And then we'll do the comparative analysis of both the case studies to give you the overview of what's the mindset of how South Korea manages their waste and how Japan differently does it. And finally, we'll end our discussion and session on understanding what lies in the future of urban waste management and how the emerging technologies can help us shape to reach us like a smart cities or a circular cities and economies. Yeah. So as you can see, there is one article which I came across that's probably for the Kerala, where it was mentioned that Kerala's waste strategy is not sustainable, and there is like these. This is a picture probably of a landfill site. Not just Kerala, but there is also cities. If you talk about say New Delhi as well, it's known as the capital city of India. But when the moment you kind of like from the outskirts of say from Punjab side, if we try to enter into the New Delhi, the first thing we see is a huge pile of landfill uh, on the entrance itself. So that doesn't give you the right sight actually, if you're the capital city of the country. So there are not just the cities in India, but in global, this was the data shared by the World Bank. So World Health Organization. So around 2.01 billion tons of waste, municipal solid waste, is kind of like generated globally each year. So that's you can understand the volume of waste getting generated from major cities. So it's projected that by 2050, the waste piling up will escalate up to 3.40 billion tons, and 33% of waste is still handled in a environmentally unsafe manner. So there are people who are getting exposed to these hazardous waste, and then they're getting disease from these. So the key drivers, what could be the key drivers which have been contributed to this uh, waste situation? So as you already know that first and foremost is the rapid urbanization. So the more and more cities are developing, we are using uh, our means to kind of like uh, improve our livings, but that's in incredibly helping or like affecting the environment. And of course, then there is population growth. The more demand is for the products, the most waste is being generated. And then there is economic development. And like some of the countries, uh, like take it for consider, for example, US. So US has this mindset, like the people over there has this mindset that they are kind of like the from the top country of the world, and they don't need to kind of like take care of the environment, and it's kind of like they have to live for themselves and they don't worry about the future generations. So that kind of mindset is going to harm the humanity or the country in general. And of course the evolving consumption patterns for developing and developed nations. So right now, the consumption patterns has changed. There are one use cutleries and various products which are being used and thrown away. So that has generated lots of waste. So right now, what was happening is there was the people who are trying to manage the waste. They were following a particular scheme of things. So what we need to do is reimagine the waste as a resource. That's the most important thing we need to understand. So what was the old way? The old way was okay, take, make, and dispose. So whatever we try to make, we extract the resources, raw materials, and then we kind of like manufacture the products. And then once the products are being used, they are sent into the landfill site or incinerator. So we are not bothered about how the product will end up or what waste would be generated. So it's kind of like this one-way cycle. We extract the resources, manufacture the product, and then eventually, once the use is completed, we discard it into the landfills. So what this has resulted into the resource depletion, environmental pollution. So we are having overflowed landfills. So there is not much space as to where to treat those solid waste. And there are, of course, greenhouse gas emissions, methane gas emissions, and ecosystem degradation. So, what needs to be done? So, first and foremost, the mindset has to be changed. So, some of the countries right now are following this concept of circular economy. So, what is meant by this circular economy? So, it's the future. It's like restorative by design. So, in the circular economy, whosoever is kind of like manufacturing the product or making the product has to understand that this product, he has to use those materials so that these products are going to be recyclable and replenishable within the ecosystem. So it has to be a circular economy, not just one way direction, but has to reuse and then again bring into the uh, chain cycle. So we design out of waste, we create products that are durable, repairable, and fully recyclable. So keep materials in use. We have to maximize the product lifespan through reuse, repair, and remanufacturing. And of course, regenerate system and return biological materials to nature to replenish ecosystems. So as we move forward in the presentation, so I'll give more examples of how we can like implement the circular economy principles. So what this will do is it will result in resource preservation. So there will be reduced pollution, economic value creation, because you are not now considering waste as a waste, but a resource to reuse it again. And then it will help also to thrive the natural systems. So there are other tools which can be used to monitor the amount of waste being generated. So how technology is revolutionizing the waste management. So there are some of the cities have also already installed smart bins. So what these smart bins have is they have sensors that can monitor the fill levels in the real time. And this can help in optimizing collection routes and reducing unnecessary. So imagine that there is a city, there is like in the morning, there is a truck which has to circle around the entire city collecting the waste. And if you have installed smart bins, which kind of like give the information digitally to the central server that the bins are almost full or they are say not full, 40% full. So that route the truck will take will be optimized and it will be like saving on the transportation cost as well as fuel consumption. So all those bins who are almost close to fill or say above 90% fill, so the truck will move on those directions collecting the waste from that sections, and this will kind of like save on the energy aspect. The second important digital tool, which is like the IoT and big data. So what does this tool is helps us better understanding of the forecasting demand. So what's the waste generation scenarios, what type of waste are being generated, and how we can operationally uh, control that waste generation by implementing certain laws. So the more data we have, the more visibility we get as to where we can focus our direction and do the necessary steps. Then there is RFID tracking, which is also implemented in South Korea. So I'll explain more once we discuss those case studies. So what this tracking does is this track waste from source to disposal, and then it enables you pay as you throw systems and full accountability. So it tracks how much waste you are generating, and then accordingly you have to pay. So you are becoming responsible of how much waste you are generating, and in a way, if you have to financially control the paying the cost, so you will change your mindset and automatically try to lower the waste production. Fourthly, the AI and robotics. AI and robotics are now being getting used in each and every field you come across. So what they have done is they have kind of like made our work a lot more easier in terms of say there are robots which can quickly and efficiently segregate the waste by detection cameras and vision technology. And of course, there could be robots installed at the places where the wastes are a little bit, say, hazardous in nature. And if a person is exposed to them, it can lead to diseases. So it's better to employ robotics over there to help us sort the waste generation. Then the new emerging technology additionally coming up is blockchain technology. Blockchain technology is mostly has been used for say in other aspects say cryptocurrency and those situations, but blockchain has recently been used in the waste management as well because it can help us track the recycled material through the entire supply chain. So I'll be explaining in detail about this technology as well in the future slides. So these are some of the one of the tool like smart waste management, IoT and sensors. Those there are smart bins installed. As I mentioned you, they are in some of the cities in Seoul, in South Korea as well, especially Seoul and some of the stations. They have installed smart bins. Uh, they are automatically operated through solar powered compactors, and they have like fill level sensors. So the moment these bins kind of like completely fill up, and they kind of like let you know as to when to collect that bins. In the majority of the residential complexes, although the waste is being managed by pay as you generate the waste principle. So I'll explain that in the later slides. So it's not like that the common waste bins are available to throw the trash across the streets, because the common bins cannot track how much waste you are generating. So it's the duty of each member of the or the citizen or whosoever is living in that country to kind of like pay for the waste they are generating. Then, yeah, as I mentioned you earlier as well. So these kind of a smart bins, what they help is they can kind of like help you save on the fuel consumption. So AI algorithms can create efficient collection routes, and then you can collect the waste by saving on that fuel consumption. And then there will be also environmental impact. So fewer truck movements will mean lower emissions, and there will be cleaner streets with less overflow. So, so what are the insights that makes that data-driven decision will help us in urban solid waste management? So first and foremost, what is important is through this metrics, we can gather the waste metrics. Uh, what do you mean by waste matrix? So it gives you the idea, okay, this type of waste is particularly generated from this section of the country, or where are these kind of like industries available. So how much metrics of, say, plastic waste is getting generated, how much the glasses or cans are generated. So all this trends we can gather through, say, decision making tools like the data driven tools, which will help us in decision making. So once we identify these patterns and trends, we can do the analysis. Okay, uh, too much of waste is not segregated, or this kind of a waste is being generated from certain sections, and we need to kind of like manage that waste, and there we don't have those facilities. So accordingly, the government can prepare those facilities, say whether it's an incineration facilities, or say it's kind of like a composting facility. So this data collection serves as those tools and give us a trend, okay, over the period of years, how this waste generation of particular type is increasing over the time with the growth of population. So we can be prepared about uh, setting up the ground facilities at the moment. Then it, of course, yeah, as I mentioned, it gives us the actionable recommendations. So what we need to do, which kind of facilities we need to kind of like promote, and so that we can manage the waste well. And finally, the implementation. So we can optimize the waste management systems. So the also one of the key aspect in the waste management is now the role of AI. So AI currently is being used in sorting and recycling of the waste. So on the right side, if you the picture you are seeing is of a robot which is capable of segregating the different types of plastic waste. So this is one of the patented technology of a company in South Korea. So what this robot can do is it can segregate around 7 different types of waste. Like among the plastic wastes, there are different categories of subcategories of plastic wastes, which is kind of like, say, PET, PE, and PP, and other types as well. So all those 7 different categories can be sorted, and the efficiency of this robot is around 99.3%. As compared to human, the efficiency is much higher, because human employed on similar belt were able to segregate these types of different waste by say 65 to 70% accuracy, and this robot was capable to segregate with an accuracy of 99.3% and with the sort rate of around 96 pieces per minute. So how this works is they have the AI cameras identifications on the conveyor belts. So that camera recognition already in the backend, there is the processing machine learning algorithms, which classifies that waste types. So there are billions of pictures being run to develop that algorithm, wherein it identifies through imaging what kind of waste it is, and then it automatically sort it to different appropriate streams. And in this way, we can kind of like recover more materials with higher purity. So what types of works are currently being automated and wherein the robotics are being employed? So most of the currently in South Korea as well as in Japan and maybe in some other countries as well who are moving on to the automation. Mostly these robots are being used for precision sorting. As I mentioned you before, they kind of like quickly process it and then segregate into different types of the streams. And the best part is like, of course, these robots can work tirelessly and they won't feel fatigue and they can continuously work for efficient and long duration as well. The main important aspect of this automatic automation or robotics is the safety benefits for the humans, because some of the say waste sites, if you see, the conditions are very bad for people to work over there, so it poses a dangerous risk for them. So if robots can handle those dangerous materials, it can of course help the human beings avoid certain injury or risks. And then we can also integrate to across numerous lines, connecting different machines and processing lines so that can handle more volume with lesser. Now, moving on to the other important technology which I mentioned before was blockchain for waste traceability. If you see the figure on the right, this is one of the paper which was published in uh, uh, in one of the journal in 2023. It's kind of like study that is published in Vietnam. So they have used this blockchain-based technology, traceability. So all the waste, different types of waste which are being generated, they are kind of like tracked, uh, be it from hospital waste or industrial waste or other different type of areas. So they are kind of like segregated into various streams as paper waste, biomedical waste, and different kinds of waste. And every waste is kind of like having a particular contract. Okay, this waste, this percentage of glass waste is being generated from say hospital or this industrial area, and that it's kind of like saved in the ledger, and we can have a digital tracking of all the waste batch which is being received. So this blockchain records every movement, similar to the blockchain in say this cryptocurrency or uh, yeah, those currency coins. So it's all recorded in the digitally form. So you know, okay, these are kind of like how the regulators are addressing this disposal, what's the starting point of this waste and how it's tracked, how it moves from one part of the city to the other. So everything is kind of like keep a track record of it. And then you have like certified recycling materials which can command premium prices. So you know, okay, these are the certain metals which are of use, and then they are generated from this kind of section, and this is how much waste is being generated. And then of course if someone wants to reuse that waste, they can kind of like know, okay, this is the amount of waste that would be available for reuse. So yeah, after discussing those digital and monetization techniques and how we are kind of like better manage the waste, the key aspect of all this waste management discussion lies in how the policy is being shaped and how economic instruments are driving the behavioral change. So that's the main rules of the game, which is kind of like very much important to manage the waste at a particular city or an area. So first is extended producer responsibility. So extended producer responsibility is one of the policy which is kind of like implemented in Japan. So what does this mean is that the manufacturer who is producing that product or making that product, he is responsible for the end of the life cycle disposal and recycle. So imagine a particular manufacturer who is going to manufacture, say, refrigerator or an air conditioner. So whatever materials he's going to use it for making that particular product, while making that product, he now knows that after, say, 5 years, 10 years, when uh, the customer disposes of this product, he is going to directly call them to for pickup, because it's the responsibility of the producer. They are the in charge of kind of like end of the life disposal. So what does it do then? So it, as a manufacturer, you think, okay, I have to make sure that I am using those materials which is kind of like recyclable. And when the product, even after the life cycle comes back to me, I can reuse it in making the again the new product. So this changes the responsibility of the manufacturer, and now he's becoming more responsible because he is the one who is going to control the end of the cycle disposal and recycling. If he's not able to, then he has to pay the recycling cost to whosoever is taking care, like the government officials or whosoever facilities is taking care of that disposal. He has to pay them. So that's how it goes, this EPR responsibility. The second thing is pay as you throw. So the citizens pay based on the amount of non-recyclable waste produced, creating direct financial incentive. So this pay as you throw principle is in practice implemented in South Korea as well. So the more amount of waste you generate, the more you have to pay, because there are fixed bags, and then like the volume based system, which I'll be discussing in the next slide probably when we do the case studies. So they have to pay. The citizens have to pay for whatever the treatment cost is. So government will collect that waste, and there are like volume-based fixed bags wherein we have to kind of like dispose of the waste, and we are upfront while buying that bags paying the treatment cost. So the more waste we generate, more bags we are going to use, more cost we are going to face. So that way, it kind of like in a way pressurizes you to generate less waste, and also try to kind of like segregate, because non if you see the word here written, it's non recyclable waste for which you have to pay. For recyclable waste you don't have to pay. So for recyclable waste you can just segregate it, and if you tend to put that non like the recyclable waste into the non-recyclable bin, then of course it's going to be a financial burden on you, because that bag is going to get filled quickly. So, and the third one is landfill bans and levies. So of course I know that currently maybe it's not practically feasible in India to kind of like put a total ban on the landfill, but this is something that has been done in elsewheres. So they make disposal most expensive and least desirable option for waste management. So there is no option of landfill. So anyhow, you have to kind of like treat that waste, reuse it, the waste, or whatever the waste. There is no landfill available for kind of like disposal. Mandatory separation laws, and this is very much important actually. We tend to I see, like when I go back to India in my hometown as well. So what we are doing is we are not segregating the waste. We are not separating the waste. We are just putting in one bag and just throwing off. So that puts a lot of burden actually on the treatment management sites as well. And we are not able to recycle the valuable materials because all is getting disposed of together as one. So this separation law is very much important if we are to kind of like move ahead with this in make our cities say cleaner from the waste. So yeah, now going on to the moving on to the two key aspects, two cities, the case studies we are going to study today. So South Korea in 1990s had this situation wherein the there was no area available for the land, say landfill disposal. So it got saturated in 1990s with landfills critical levels threatening the public health and environment. So there was this like landfill crisis in 1990s. So that that led to the all the government heads to get together. So they said there were lot set together. There were lots of deliberations and policies makers who were discussing what needs to be done. In after 5 years of deliberations and consensus, in 1995 they implemented VBWF system, which is volume-based waste fee system. So what that system says is that citizens will purchase government issues bags for general waste. So it's for general waste. So recyclable waste, you don't have to pay. But for the general waste, which you are going to say generate, be it say the trash bags or like the paper bags or say wrappers or those things or different kind of general waste which is termed as general category, you have to pay for that. You have to kind of like collect the bags which is government issued bags, and then we have to kind of based on the volume the fee would be charged. So bag would be say 5 liter, 3 liter, 20 liter, based on how much amount of waste you are generating. So what this did was, so it gave up a direct incentive to the public to segregate the waste, first of all. So now they know, okay, for general waste, they have to pay. So if we are going to throw all the waste together into one general waste, of course, their financial burden will increase because it's kind of like they have to purchase the bigger bags to dump all the space. So it triggered their mindset, okay, no, we cannot pay so much amount for the waste if we keep on putting in the same bag or something. So we have to kind of like segregate. So you're not informed to do it, but in a way you are have to do it because there is a financial burden about it. So recyclables were collected free of charge. So people tend to like segregate the waste, and then bottles and cans and say batteries were segregated and separated, and then the general waste was put together. So there was powerful economic motivation behind creating this kind of like situation. Food waste revolution was introduced. All the food waste was banned from landfills. So now the food waste is is to be converted into compost and biogas. So we have bags here wherein we have to kind of like separate the food waste. All the food waste, we are paying for the treatment cost of the food waste, say composting cost, and the food waste is then converted into compost and biogas. So they are like not dumped into the landfill sites. And then they are also tracked by RFID weighted bins. So what this has resulted is that this resulted into dramatic reduction in landfill waste and world-class leading recycling rates and sustainable waste management. So from being the landfill crisis, South Korea turned the entire tide into becoming a recycling leader just by the change of one uh, perspective and one implementing a particular policy, which is BBWF system. So how the management happens in South Korea. So it's kind of a more deep dive into it. So first and foremost, I mentioned to you is volume-based waste fee systems. So citizens pay for non-recyclable waste and then they purchase the government approved bag. And the system is also referred to as pay as you throw model. So the more waste you generate, the more payment you have to do for the treatment cost you have to do. Then mandatory recycling waste is sorted into 10 different categories. So plastic waste, metal waste, food waste, and then you have say glass waste separate, and then the batteries are also disposed of separately. So all those, like there are 12 different sort categories. For households, we have kind of like 3 different categories, but of course, if there is say batteries, and we dispose of separately as well. So that comes into the recyclables, and then they are taken up free of cost. Plastics is also taken free of cost. These days also we have in various parks I have seen the government has installed the plastic bottle collection like a machine wherein if you put the plastic bottles, then for each one plastic bottle, they recharge your account with 100 won. So 100 won is kind of like 6 rupees in India. So for every one bottle you return, you get 6 rupees. So most of the people are doing as well. They are going to those stations when they have like plastic bottles collected, and then they kind of like put in this facility. It adds on. Its amount is small, but if you keep on recycling yourself, the amount gets credited into your account. For each bottle, it's kind of like 6 rupees. And then there are, of course, we already talked about smart bins installed, wherein there are fill level sensors there. And a high level of food waste recycling is done. About more than 95% of food waste is recycled and often converted into valuable resources like animal feed, bioenergy, and compost as well. And 60% of non-recyclable waste is incinerated, generating electricity and heat for the district heating system. So all the non-recyclable waste, already the consumers are paying for it, the treatment cost. So it ends up into the incineration facility. Incineration just turns that general waste into an ash, and then the biogas or whatever is generated is to used for making the electricity. And in this way, we can kind of like promote zero landfill and in metropolitan cities and can foster urban environments. So you can see on the left side of the screen, there is an RFID-based waste weighing system. So these kind of systems are installed in the high apartment complexes, which are kind of like, say, 20-story or 50-story buildings. You can see at the back, there is kind of like apartments of typical apartments of South Korea. And in that apartments, they have a common waste collection area for each of the site. They have a common waste collection area, and then their RFID based waste weighing systems are installed. So whosoever are the residents, they kind of like have a particular tag uh, in to their house number, and then once they can access this RFID system, and then they dispose of their food waste. And this bin kind of like collects and measures the waste quantity, and then uh, each of the resident is kind of like paying certain maintenance charges. So based on the amount of food waste they are generating, it gets deducted from them, or like they are asked to pay the maintenance charges for this waste, and monthly they have to kind of like pay it. So that's one kind of a system in those apartments. For the others who are kind of like living in villas and the other houses, so we are also the business owners like restaurants, we have these kind of like bags available. So you can see like there are different colored bags for general waste. So this is kind of like 50 liter bag, and this is kind of 20-liter bag, and it says like Suregi Butong. Suregi Butong means waste bag. Butong is bag. And then Ilbonyong. Ilbonyong is general waste. So general waste bag, it is kind of like used for the waste collection. And then you have like this yellow colored bags. This yellow colored bags are used for food waste collection. So the cost of say the above this 220 liter of general waste bag is around 660 won. 660 won is, say, you can say approximately close to 240 rupees. So yeah, you can imagine like 20 liters of waste you are throwing, and then you kind of like you spending around this much money for each bag of the waste generated. And then this is kind of like 300 won. So kind of like 18 rupees per 5 liter of this bag. So this is kind of like food waste which is being generated. And yeah, you can see like this, if you can see this is kind of like it. Some of the cities have started now mentioning because the foreigners have increased. So it says Umshik Saregi, which is kind of like food waste. And they have also started writing in English as well, food garbage waste. You can see in the bag. So this kind of like yellow bags are available in the city where I am living. It's kind of like 3 liter bag. And then there is also bags for like a burnable waste, which is kind of like also referred to as incineration waste. So this is kind of like incineration bag. So this is written as incineration garbage bag. So you can see here. So it's kind of like 20-liter bag. So we have to buy these bags from, say, convenience stores. So we have to pay for the. It's kind of like we are paying for the waste treatment. It says flammable garbage. So whatever who is waste, general waste, which is going to be incinerated, it's mentioned there. So they have all this written in the bag itself. That also it specifies, okay, when it's to be collected. So it says like Iloil to Mogioil. So like Sunday to Thursday, they will be collecting this waste after 8 p.m. So so that's how the specification is mentioned on those. Uh, and when no, so after 8 p.m. No, it's kind of like you had to put the waste outside after 8 p.m. and it would be corrected and before 5 a.m. So in between this, you have to kind of like keep the waste outside, and then they will be collecting that waste. And if you keep it on the other sides, other days, they won't be collecting it. So that's how all the instructions are given to the residents who are kind of like living there. The important aspect also to know is it's kind of like sometimes you feel like, okay, it's too much overwhelming and you need to understand, and there's too much like in the mindset of when I came here, say in 2018, it seemed to me like too much of tedious work, because we are used to kind of like just putting in all in black bag and throwing it. But eventually you need to understand, and now it's kind of like you feel responsible enough to kind of like segregate those waste, uh, and of course save on the money aspect as well. So yeah, so that's the case of South Korea, how the waste is being managed in South Korea. I've been to Japan as well. So there also the waste management is quite good. I haven't seen trash bags outside, so I was wondering, because in Korea you see like after 8 p.m., as I mentioned it, because you have to put the waste after 8 p.m. and before 5 a.m., and then the garbage trucks come around 6 or 7 to collect the waste. And if you go outside for a walk at the night, you see so many garbage bags being collected at the side of the roads, and it's not good sight actually. So why I was wondering when I was in Japan that I don't see any bags outside. So then from inquiring from a local person, I came to realize that they are directed to put the waste after midnight, like the 12, and it's kind of like before 8 a.m. So the people who is kind of like going out, so whenever this, they don't tend to see the waste on the streets, because it's kind of like after 12 midnight and before 8. So by the time 8 a.m., it will be collected. And when there is kind of like time of us to go outside or the people to go on the work, the streets would all be very much clean. So you don't tend to see the waste generated. And also they have posed kind of like penalties if you put the waste bag outside before that time. So you're not allowed to put the waste outside before that time. It's kind of like during that time only. And then there are different days where you collect the different types of waste. Of course, in South Korea is also similar. So for cardboards and other type of waste, there is a different day, and they will come on that particular day to collect that kind of a waste. And for Japan as well, it's kind of like designated days for the plastic or recyclable material collection, or the food waste. Food waste generally tends to be collected on all days, barring, say, weekends. And then that's how you put the waste outside. Now, moving on to the case study of Japan. So, what Japan does is, in case of Korea, they uh, kind of like made a policy wherein uh, where the citizens had to kind of like pay for this, the waste generated. In Japan, it's kind of like more of a cultural thing. So they introduced this system. They use this system kind of like motenai. Motenai mention is a term which is used for a deep sense of regret concerning the waste. So it's kind of like cultural philosophy in so that they respect their resources. So whenever they generate this waste, or like generate too much of trash or waste food, they feel from in deep inside they feel this feeling of regret. So that's culturally ingrained. So they have this mindset of not generating waste or trying to recycle the waste whatever possible and segregate the waste. So that's the cultural mindset of their discipline and design. So the situation of separation is much more complex than in South Korea, because it's kind of like often 10 plus categories. And then you kind of get confused as to you have to separate the burnable and non-burnable PET bottles, other plastic bottles. Even the plastic categories are different, and even the glass bottles are segregated by color. So dark color bottles are separated, transparent bottles are separated, cardboard cans, and these are kind of common in both countries. But yeah, the glass bottle separation by colors is kind of like unique to Japan, and then burnable, non-burnable, and small electronics. So each municipality has their own rules, and then that kind of like rule composition is provided to all the citizens how they have to separate. Uh, so this is the first thing, the cultural foundation, Montaigne principle. The second is the EPF, which I mentioned to before, like the consumer pay fee and the manufacturer takes back. So manufacturer take back principle, like uh, so manufacturer has the responsibility of collecting, the legal obligation to collect and process the used appliances. So manufacturer can't say no. So the moment as a consumer I feel this say this air conditioner is no longer working, air conditioner is not working, or this electronic appliances is end of the life cycle, so it's not functioning, it's damaged. So I just need to call the manufacturer and tell him, okay, you can we am done, this product is done, you can take back this appliance. So they have the legal obligations to take back those appliances. So in a way they will manufacture and produce those appliances with better materials so that it's recyclable. Of course, recycling fees is paid up of for TVs, fridges, and air conditioners. Consumer pays the fees and to some of the appliances, and then manufacturer has to take back and then kind of like process it. Uh, and then there is high recovery rates, so achieving around 80% recycling rates for home appliances. So there is a law which is referred to as Home Appliance Law, which was passed in maybe I think 2001, which wants all the home appliances to be recycled. So this system processes approximately around 13 million appliances annually, recovering hundreds of thousands of tons of materials, which are kept out of the otherwise would have ended up into the landfills. So this upfront fee cost creates transparency and accounting. So while the consumer is buying that equipment, there is already a fee included in that. So upfront fee is there of recycling of when disposing of TV, fridges, and everything. So you know there is an accountability, and also the manufacturer is obliged to continuously work for improving the product design, because he is the one who has to kind of like take up the appliances back and reuse them. So in Japan, they followed reduce, reuse, and recycle. Nowadays, it's kind of like 5 hours policies, which needs to be implemented and which is promoted also widely in India as well. But I'm not sure how to what extent these 5 hours are kind of like implemented. And extensive waste segregation is happening. Uh, there is one city in Japan which is referred to as Kamikatsu town. So there they are kind of like segregating the waste into 40 different categories. So imagine like there are 40 different categories and you have to kind of like segregate and look into, okay, dark color bottle, this segregation, and light color bottle, this plastic here. The cap is to be segregated separately. So, but the people are doing it. People feel their responsibility of segregation, and then they are now well aware of how to do the segregation. You can see the image below. That's like a small town. They have like one small kind of like yellow colored bins to segregate the waste, and then they have these posters or images to guide the people as to how to put those waste. So yeah, this is kind of one of the Japanese town with 40 different categories of recycling. incineration and energy recovery, the waste which is not uh, recyclable, it tends to end up in incineration facilities, wherein it's being kind of like incinerated for and produced to use the electricity and heat. And then it adopts the circular economy laws. Like for the circular economy, I told you that it whatever product you have to make in a way it's kind of like eco design, because it has to eventually take back. So it has to kind of like complete the cycle. You have to reuse it, uh, recycle it. So you have to kind of like follow the circular principle laws. And this kind of like helps to develop the eco town projects. So the Japan is also fostering and investing too much into these kind of projects wherein, yeah, where it kind of like waste from one of the factory is taken as a resource for the another factory. So it's kind of like fostering sustainability. Of course, as we discuss, Kamikatsu City, which is kind of like considered as zero waste city. So it exemplifies commitment to sustainability with 80% waste recycling rate and driven by citizens. And citizens themselves, actually, they are kind of cleaning and sorting the items before recycling. So on the right side, you can see like this is kind of like very much common, right? 6 different types of waste bins. If you uh, go to Japan and each of the subway stations you exit, there will be these kind of like multiple bins. 6 is kind of like minimum uh, number of bins which are already installed, and then you can have to segregate accordingly. And on the left side, you can see various designated bags for different types of waste, be it say burnable garbage or non-burnable garbage or other food waste. So you have different colors of bags for each different types of waste. And these are generally translucent bags. So it's kind of like you have to segregate it properly. Otherwise, they don't take the bag. Because if you are mixing it, then they don't take the bag. So this happened with me initially as well. So when I came here, so of course I didn't know how to segregate it and which kind of colored bag is for which purpose. And then there was a like Indian colleague who kind of like also to some extent was misguided. He didn't knew actually, but he was confident enough. So he told me, okay, the yellow color bag is for wet waste. So he didn't say, told me it's kind of like just food waste. He said it's wet waste. So food waste or whatever wet becomes wet, you have to put it in there. So I was kind of like putting in the cleaning towels or uh, tissues into that food waste as well. And then in one case, probably they didn't took that bag and then put a note over there, and then I translated it. And then I realized, okay, this is just the food bag, and I don't have to put the other waste into it. And of course, the where I was living, the owner was also kind enough to help me. Okay, this is teach me as to how to separate the waste. But that was the initial couple of months I kind of like struggled it, but then it became a routine and a duty, moral responsibility as to segregate different kinds of waste. So yeah, as we have now seen the comparison of 2 different countries who have kind of like extensively adopted this waste management strategies. So what's the comparative analysis? So what's the strategy of one country that differs from the other? So primary driver in South Korea, as I mentioned, is in economic incentive. So waste, volume-based waste fee they have charged. So that's the primary driver resulting into waste segregation and waste management. In Japan, it's more like a cultural and regulatory thing, Montanai system, and then extended producer responsibility. So waste separation is much simpler in South Korea as compared to Japan. Japan is kindly highly complex, hyper localized. So yeah, it's kind of like in Korea, you separate plastic waste, but then there are in the plastic recycling facilities, there has to be those robots who are segregating different kind of plastic waste into different waste streams. So in South Korea, it's relatively simpler, but of course, Japan initially they have more categories and they have their own advantages as well. South Korea is also using RFID for food waste management. So they have also high technology use. Of course, Japan is also having sorting facilities. There is also high technology use. And exceptional, their key motive reason for the success was that they rapidly decreased the landfill waste reduction. So they kind of like the landfill is not an option. So they made it clear to the public, we don't have to dispose it on the landfill sites. That's not an option for us. So we have to manage the waste. And of course, in Japan also, there is high purity recyclables, and then they are very good in segregating and recycling that as well. So both the countries have a common is a strong public education. So if I talk about education, so today morning itself, actually, I received a message yesterday from my son's kindergarten school. So they had this training, waste segregation training program for the kids. So my kid is going to kindergarten, so he's from this stage only learning as to how to segregate different kind of waste. So there was a poster, and that knowledge was given to them, and then actual hands-on practice as to where to put this kind of waste was demonstrated in the school today. So it has to be ingrained into the education system. So right from the beginning, kids and get to know, okay, this is their moral responsibility of segregating the waste. So comprehensive awareness programs and campaigns are needed to bring this kind of an awareness among the kids, and of course the citizens as well. And then government commitment. So you have to kind of like consistently enforce some policies, and there should be a long-term strategic vision. That it could be like, to some people, if we force something, they are kind of like repelling, but there has to be kind of like understanding that this has to be done, and the government has to kind of like develop those facilities and mindsets to take care of this. And then share responsibility, of course. As an citizens, we should have that share responsibility of managing this waste, and and our producers also should be accountable of what kind of materials they are using for producing the particular product. So what lies ahead? So what the future is about waste management, and how should we be kind of like utilizing it to manage the waste properly and controlling the waste management. So road ahead, we have to be convert waste to energy. So these days, advanced thermal treatment facilities are being installed, gasification and pyrolysis. Their efficiency has increased, and this results into lower emissions, and then of course generation of electricity as well. There are biorefineries which can convert products such as bioplastics from organic waste streams. So that's something which is also future of waste management, which is going to happen. And then digital product passports. So digitally, we can, okay, we can take up, so for example, we know we are buying particular products, say this perfume bottle. So when we scan the QR code on the product, so it will give us the digital passport or the life cycle assessment of how this product is going to end. So would this be reused after consumption, or how it going to be recycled? So we will have digital passports of all the products, and from how the life cycle has happened, and how it will there will be the end of the life cycle, or how it will be recycled back. Then AI powered circular design. So softwares will particularly help us in understanding how much and which type of waste are being generated, and how they can be reused, and what could be the resource which is we can incentivize so that we can perform the circularity. So this data is also very much important for understanding. The couple of things which I also feel is going to be the future of recycling or future of waste management. One is the chemical recycling. So we need to kind of like come up with the technologies wherein we can break down certain types of plastics into their molecular binding blocks, so that this gives us an infinite recycling options. So right now, the plastics, some of the plastics are getting recycled, but there are certain section types of plastic which is not recyclable, and they tend to end up into the, say, ocean waste or dumping sites or those kind of sites. So if we are able to break down those plastics into, say, bioplastic forms or into a much molecular form from where they have been constructed, it would help us to recycle infinitely. Then urban mining. So right now, whenever we need any particular materials or precious materials, we have to kind of like go for more coal mining or gold mines and all those to extract those valuable materials. What if we are able to extract those valuable materials from the end of the life cycle of, say, electronics or buildings? So there is a systematic recovery of valuable materials from end of the life buildings or infrastructure or electronics. So they themselves become as mines rich in recoverable materials. So we recover materials from those products and then reuse it instead of extracting virgin materials from the mines and then also leading to environmental pollution as well. So these are some of the areas wherein the potential can be tapped in and better management of waste can be done. And yeah, before coming to the close of my presentation, so what needs to be done is we need to kind of like develop a zero waste city culture. So yeah, you might say that it's easy said and done, but at least the starting effort is required to kind of like reach that vision. And there have been like countries like, of course, I discussed two cases, there might be more. These two are very well prevalent cases of South Korea and Japan, wherein they have done those, led by examples to build up those zero waste cities. So for building up those zero waste cities, we need to focus on four key aspects. One is circular economy, as I discussed. So we have to make sure we are going to reuse the product at any cost, and we there it's, would be reusable streams, and we have to design in a way that uh, yeah, this product can be reused again and again. So, and of course, I'm surprised actually when we can see that why so much of waste is being generated in India. But if we see our example at home, uh, our mothers are kind of like the best examples of how to reuse, because it's kind of like they don't discard any box of, say, whether, yeah, any container. So you use it for some section or then even the plastic bags are continuously reused again and again. So we have ingrained in our blood as well the circular economy principles, but we need to kind of like implement in broader scale as well. Then we have smart technology. Of course, we have already tools to efficiently and optimize our systems and kind of like improve the transparency. Most important is the cultural shift. So public participation is very much important, and they should be aware that it's our own responsibility, that we have to kind of like manage the waste and not pollute the environment, and that's how it would be done. And then, of course, the strong policy. Economic instruments can drive lasting behavioral change. So if we are going to, if everyone has to pay for what they are polluting, then of course there will be a behavioral change as to what kind of things we are going to buy, because we don't want to kind of like pay too much for waste treatment costs. And in the end, like, I must say, of course, whatever has worked for South Korea might not work for India, or whatever worked for Japan may not be suitable. But of course, there is no one size that fits all. But if we kind of like have the right intentions to do, and we adopt best practice in terms of local context and cultural context, there should be actually we should be able to achieve the goal of kind of like zero waste cities. But we have to kind of like stay committed to this core economic principle of circular economy, which is very much important for achieving this strategy. Yeah, in the end, I'll thank you all for listening to my presentation patiently. Kamsamida, and thank you so much. And I'll open this session for taking up your questions if you have now, moving forward.
Participants, if you have any questions, you may kindly ask.
Yeah, if you're hesitant to directly ask, then you can also put in the chat box as well.
You can also type it in the chat box. So I have a doubt regarding this blockchain for waste traceability. So what type of waste data can be captured for this blockchain technology?
Generally, all the time kinds of the waste data is collected. Like
Okay.
the countries which have say 10 types of different waste segregation. So this blockchain technology, for example, in case of Vietnam, they implemented for around 10 different waste categories for plastics, glass, and then food, and then say biomedical waste. So they have segregated different 10 around different categories of waste, and it's being tracked because once it is collected separately and there is a segregation, and then you scan the code and you know the weight, so it can accumulates, okay, from this cluster of a city, this much of glass waste was generated, or this much of electronic waste was generated. So that kind of a segregation gets accumulated, and you have the like all the data accumulated. Okay, for a particular colony or a particular city, this is the waste generation scenarios.
Okay, thank you, sir. There are so many questions which is there in the chat box.
Okay, so what is
What is an
what
integrated waste management plan and how does it incorporate the waste hierarchy?
prevention, reduction, reuse, recycling, recovery, and recycle. So integrated waste management plan is mostly we kind of like club all the techniques together. So it's kind of like a very big uh, like a question to answer, not right now, because it's kind of like will take it's in another chapter as well, integrated waste management plan. So but the thing is all the waste which is being generated from different sources, be it industrial waste or biomedical waste or those waste, they have to be kind of like collected in different uh, waste collection systems, and then they have to be kind of like treated in a bit different way. And the first and foremost, as I mentioned in my presentation as well, the key aspect of any waste collection facility or any waste collection system is the segregation at source. So segregation at source has to be done. Once we are doing the segregation at source, we get to know, okay, which types of waste are recyclable, and then we kind of like reuse it and recycle it to those facilities. And prevention is the waste prevention is of course based on also the type of policies which is implemented. For example, I mentioned you the extended producer responsibility. So in that case, if a manufacturer is liable to take care of his product, he has to take back this product, then he will kind of like prevent using the materials which are non-recyclable. So there will be prevention at the source as well. Of course, the waste generation prevention will also be at the consumer level as well. They are not going to buy things which for which they are going to kind of like pay. So they try to minimize as much as possible. For example, if we are going uh, in my case, for example, if we are going to coffee shops, so most of us are these days taking our own tumblers with us, just getting the coffee refilled into that tumblers and not using that plastic or the paper cups they are using. So that's how it's happening. So it depends on all the situation, how the waste management happens, and then uh, throughout that system, the different possibilities of reduction, reuse, or recycling and disposal will change depending on the management. So right now, the disposal system, as I mentioned to you in South Korea, there is no landfill. So we don't have the option of putting or disposing the waste into the landfill site. So it's being managed. Uh, Food waste is converted to compost, and then the other waste is converted to taken into incineration facilities as well. So yeah, The other questions, primary sources and
Uh,
classifications of municipal solid waste. Okay, domestic.
and other questions are there. In South Korea, what is the disposal mechanism for non-recyclables?
Yeah, so non-recyclables, which I mentioned to you, like these are like the general, they are considered to be the general waste. So the bag which I kind of like showed you, like the incineration bag. So these are the bags for the general waste. So we put, so we buy those bags from the market, like the government designated areas. We can get this bag for even convenience stores. So this is all incinerated. So this is the general waste, non-recyclable waste is got incinerated and then it converts into the ash and then it's kind of like, uh, yeah, and then the biogas and everything is kind of like reused and it's used into production as well. So that's how that waste is being.
And the next question is to elaborate a bit more on the RFID practices of Japan and Korea.
Okay,
Also,
so
any idea on the disposal mechanisms?
okay, so RFID practice is basically like you have so RFID is radio frequency detection system. So in that system is you don't need to kind of like scan something. Automatically the machine, whenever you put in that waste, it automatically measures the weight and kind of like directly links to the user's account. Because even if you are like standing at a particular distance from that machine, it automatically scans the because based on the radio frequency system. So RFID is also kind of like implemented in certain malls as well. So when, for example, when you right now, what happens is when you buy certain different, say, set of clothes, so you every time in the billing counter you get to have to kind of like scan the barcode or something like. So that's a normal way of scanning. But in RFID, what happens is you you have purchased like a set of clothes, we just put it in that basket and it automatically scans all the clothes and puts the prices. So it's kind of much faster and it kind of like then tags it into the person who is kind of like putting the waste. So RFID is practiced in, I haven't seen in Japan, but most maybe it might be there. But in South Korea, mostly the household apartments, they have this RFID based collection bins, wherein whenever the person from that particular house dispose of the waste, food waste, they have a detector, RFID detector in that bin of theirs, which kind of like adds on the amount of waste they are giving to their account. So then they pay for the whatever the cost of treatment they have, whatever the waste they are generating, they pay the treatment cost.
And there's one more question. Suggest any practice that can be implemented in India as per Indian conditions for better waste management, especially in tourist places.
Yeah, so I think India is a complex situation in for example, first and foremost, like I'll share you my example. For I'm living in South Korea, so we know we don't have like the open public trash bins available. So whenever we kind of like consume anything or use, we put the wrapper into our pocket and have to go and throw it in our homes and say bins. So that's not there in India. So I remember like last year going back to India and yeah, with my friend drinking tea and then he was telling me, "Oh, just throw the cup outside the car." Yeah. So like, सर ये इंडिया है कोई नहीं आप थ्रो कर सकते हो बाहर. So that's the mindset actually of but I didn't feel like so I of course on his insistence I somehow like was tempted to throw it, but from then there was this guilt feeling coming in. Okay, no, I am keeping the country where the like the foreign country clean, why I'm polluting my own country. So that's the mindset actually has to change, and people shouldn't throw actually the waste on the streets, and then there should not be open bins for public to throw, and there should be fines. I know it's kind of like sounds that people can that the government cannot track all the things who is throwing the waste, but in Korea I'll tell you is every street is having a CCTV camera. So if you are doing something like if you're polluting, if you're throwing waste directly on the streets, no one actually does. But if someone is doing it, directly the bill comes to your home and you need to pay for it. So that's how it happens. So of course, we have to be very much strict in Indian context to manage it, and especially in the tourist places. So if we have to kind of like we ourselves have to lead by example, so they won't pollute the places as well.
I think all the questions you have answered. We have cleared the doubts. There's no more questions in the chat box. I'll conclude the session. To conclude, today's session highlighted the global urgency of urban waste management and the need to shift from the linear to the circular systems. We have noticed, we have shared the practices which is done in South Korea and Japan, and we have saw how these practices have transformed this waste into a valuable resource. So the adoption of all these technologies and circular economic principles that it's made the building efficient, sustainable, and future-ready urban waste management systems. So I would like to express my sincere gratitude to our respected speaker, Dr. Amarpreet Singh Arora, who enlightened us with the valuable insights from innovative smart waste monitoring systems to the vision of a circular economy. Thank you, sir.
Thank you so
So
much.
before we'll have a virtual photo session. I request all the participants to put on their cameras so we can have a virtual photo shoot. Rashmi miss, after completing, please.
Okay. Thank you, Grishma. We'll move on to the next session.
Okay. Thank you, sir. The next
Thank you so
session
much.
will be handled by, thank you. The next session will be handled by Professor Deepti Dennison. Deepti, Deepti, you're on mute. Please unmute yourself. A warm good evening to all. Now, I would like to introduce the speaker of our next session, Mr. Binod J., Assistant Executive Engineer, Shujitsa Mission, into this FTP. Mr. Binod is a civil engineering graduate from TKM College of Engineering in 2002. He completed his post-graduation in Water Resources Engineering from Visvesvaraya College of Engineering, Bangalore. He joined the local infrastructure development wing in the year 2012 as Assistant Executive Engineer. He has previous experience as lecturer in engineering. He is currently serving as Assistant Executive Engineer at Shujitsa Mission under the Government of Kerala. He possesses technical expertise in digital technologies related to civil engineering, including surveying, GIS, and remote sensing. He has professional skills in open lifecycle analysis, ArcGIS, MATLAB, and IBM SPSS. Also, he's a skilled professional in artificial intelligence applications and mathematical modeling with a focus on leveraging technology for sustainable infrastructure, environment, as well as water resource management. With this, I would like to welcome you, sir, on delivering the topic Enhancing Environmental Absorptive Capacity, AI Tools and Techniques for Sustainable Development. So, welcome you, sir.
Thank you, madam. Let me try to share my screen. Is it visible?
Yes, sir, it is visible now.
Okay, I'm audible too, right?
Yes, sir, audible.
Okay. Thank you, madam, for your kind introduction. And let me straight away jump into our topic. So, if you don't mind, allow me to switch off my video to tackle the network, possible network issue.
Okay, sir. Okay, sir. You can switch off the video.
So, today we are going to discuss something about the environmental absorption capacity. Actually, the term may not be that familiar among the environmental engineer and practicing engineers. Actually, this is a portion that is often ignored or not given its due consideration in designing our waste management systems. Uh, uh, Let me get into that point by point, and I will also discuss something about what AI can do in this scenario and how it can improve our environmental systems and the environmental waste management systems. So what is environmental absorption capacity? It is defined as the ability of a natural system to absorb pollutants or waste or heat. Okay. In waste management perspective, let us stick on to pollutants and waste. Other things we can forget for the time being. Regarding our urban context, these two are given prime importance. It is also important. I'm not telling that is unimportant, but for today's discussion, we'll stick on to pollutants and waste management. Okay. Actually, this environmental absorption capacity is considered as an indicator of sustainability. Okay, often we don't see sustainability as a quantitative parameter. We usually use that vocabulary as a qualitative aspect. Okay, but sustainability is a well measurable thing, and there are so many indicators in practice, and the environmental absorption capacity is one among those indicators. Okay, and talking about resilience. Here, what does resilience actually mean? Resilience means the capacity of environment to regain its original state after getting an environmental shock or a load. So some unexpected event happens into an environment, and after that, how fast it can recover back to its original position. And resilience is a term used to denote that capacity of an environment. In environmental absorption capacity, we use some terms to represent the absorption capacity. Actually, these terms are closely related to the subsystems. For example, if for a water system, uh, uh, assimilative capacity is taken as an indicator of absorption capacity. Now, what is assimilative capacity? That is, it's suppose you consider a natural water body, it will have some capacity of self-purification or to absorb or dilute some pollutants to such a level that it is not harmful to the end users. End users doesn't actually mean human beings, all stakeholders of that water system. Okay, that is assimilative capacity of water. Then carrying capacity is another indicator. Carrying capacity, we use that term we use in two different contexts. In regarding air system, if you talk about air pollution, carrying capacity is the ability of our air system to dilute or move away the pollutants which are being added to the system through any factory or such polluting agents. But when it comes to land systems, or like a forest system or so, carrying capacity is usually counted as the number of inhabitants from a particular species, the maximum number of inhabitants from a particular species which can habit in a particular area without degrading the environment. That is the maximum holding capacity of a particular species. It need not be human being. Human being are already occupying in a higher number than the carrying capacity. You know that. Then buffering capacity of soil. These are, I'm just putting some examples. You can have n number of indicators for measuring this in different contexts. Okay. Now, if you say something about buffering capacity is that is a term coined in relation with the soil system, soil subsystem. In buffering capacity actually means the pH of the soil changes by the action of some agents. The capacity of the soil to regain the original pH level or the desirable pH level, that is known as the buffering capacity of soil. Now let's take a simple representation to understand what absorption capacity actually means. Okay. Now I have shown just a river that is coming through a small town, and the river will have some natural processes happening inside its mass. It is inside its bulk mass, like dilution and self-purification by microbes like diatoms, and such purifying agents are working in the system. Then oxygen replenishment of may be happening in the running water system. Then sedimentation may be happening. So it naturally has some capacity to add to purify the pollutants that is being added to the water. For example, if you take a bath near our in a river, it is not going to pollute the river. Okay, but if 1,000 people are doing that, it may not be the case. Okay, now how to quantify that numerically or exemplify that numerically? You look at the next example. Suppose we consider the required dissolved oxygen level in a river as 4 milligram per liter. That is what our expectation. We want to maintain the level at 4 milligram per liter. Okay, and existing minimum 4 milligram per liter. And suppose the existing DO level is slightly higher, 6 milligram per liter. Then we have a margin of 2 milligram per liter there. Okay. The desirable level is only 4 milligram. But actually we already we have 6 milligram. So we have a margin of 2 milligram. So we can use actually this 2 milligram per liter, that is the absorption capacity of the river. That means if you add some raw water or polluted water into that, if you discharge some polluted water into that, and the BOD of that additionally added water is such that it is equivalent to such that it increases the tries to increase the BOD by 2 milligram per liter, then that portion of pollution can be naturally be removed by this river system. So I didn't mean that we can continue polluting rivers, attributing to the possibility of absorption capacity or self-purification capacity. But still, there is some margin we are supposed to maintain in our water system. That's a learning that we has to have. That now I continue the discussion in the context of urban in an urban context. So in urban context, the systems are slightly different than rural context. In a rural context, most of the systems are dependent on natural variable, natural phenomena. Okay, but in urban context, many phenomena are or many subsystems are not phenomena. Many subsystems are anthropogenic. That means they are human-made. For example, urban water system. Actually, the urban water system doesn't only comprise of natural streets. It includes stormwater drains. Connecting to stormwater drains, there will be longitudinal drains running parallel to our roads. Such man-made systems will be there. Okay. Now, it also soil systems will be engineered soil most of the cases, because in urban areas you will be seeing only gardens or man-made gardens or natural vegetation is rare to see in heavily urbanized areas at least. Okay, then urban vegetation is also mostly man-cultivated vegetation will be there. Most of our selective species only will be grown in most of the urban areas. Okay. Then also, in addition to that, there is another system which is most important. That is urban waste management system. It is entirely a man-made system in urban context, but in a rural context, that the case may be different, because some load from our waste generated load will be applied to the natural environment directly in a rural context usually. Okay, then air is applicable everywhere. That's fine. The same definition applies here. I am just pointing out once again. See, suppose if you are talking about air, what do you mean by assimilative capacity of air, or uh, uh, how that becomes a variable? I mean, how the absorption capacity or the assimilative capacity is a variable. How it becomes a variable? Our natural thinking it should be a constant, and unless we unless we add some pollutants to it, until then that should be a constant, and the indicator shall remain constant also. That should be our natural thinking. But you take one example of Delhi Metro. Okay, yeah. In Delhi, suppose the Delhi Metro was placed near to a seashore like Mumbai, Delhi wouldn't have been facing this much air pollution issues. Why is that? Because the wind velocity in Delhi is not adequate to move away the pollutants added to the air. So what happens because of that? All the pollutants added will be stacked over their head, and the capacity air system doesn't have enough capacity to disperse the pollutants away from the city. That is the issue with Delhi. It is it becomes like a pressure cooker. The pollutants cannot escape from that constrained area. But if it was near Mumbai, that could have been done naturally, very easily. Okay, that could have happened. That means a city near to a seashore where we have wind working there, wind forces working there, that will have more absorptive capacity than a city like Delhi, which are generating equal quantities of pollutants and adding to the environment. So now you might have understood why it is important. Even though both the cities are generating the same amount of waste for pollutants, the treatment that we need to engage there are different. It will be different because of this variation. Okay. We all know that Delhi has it short of fossil fuels. Okay, now they are running on green fuels mostly. So in such cases, we'll have to make such interventions which is necessary based on the capacity of the environment. Okay, similar to water system, you can have a number of examples. Soil system that we already discussed. Now come to artificial intelligence. So what is artificial intelligence? How did it evolve? Uh, we have many examples. The evolution steps, we say, uh, we find many evolution steps in evolution models in different articles. But my best way of putting it is, it started from the PLCs, programmable logic controllers. That is the first origin of artificial intelligence. Or if somebody has thought of it, it should be the mechanical engineers working in that aspect and the computer engineers. Okay, you know that the logic controllers work so on simple logic, yes or no, or simple gate operations. So while handling complicated machines or plants or factories, they had a sense that they developed a sense that if they have a better system to make more than just a logic controls, it could have been better, and that should be the origin of the artificial intelligence. Okay, now how it works. Uh, See, it is like let us consider a traditional modeling exercise. For example, I want to model some one-to-one parameter. Let's say rainfall runoff model. Okay, so I have one input and I have one output. So what we do first? Well, we do the correlation check and descriptive statistics and all these things. We check for the soundness of the data, or whatever things we do. After that, we try to fix a regression model. It may be a linear or whatever. Okay. And once you fit the regression model, it will be a static equation. If you give an input, it gives a definite output. But artificial intelligence is slightly different. Okay, here, suppose I will take another example. Suppose I want to go out today on uh, some walking exercise, or I want to just walk and go some places. So I go out of my house and see that there is cloud above my head. Okay, there is cloud in the sky. So I slightly get confused whether I should take an umbrella or not. So I will think of how do I decide? Suppose it is my first instance that I see a cloud. For precaution, I take an umbrella, and I have gut feeling that there will be rain. So I go to the market or so, and I come back, and there was no rain. So I get a gut feeling that if this much cloud is there in the sky, there is not going to be a rain. That is a gut feeling I am going to get. And the next day also I see some sky. It is of having different density. It is slightly higher. Again, I take the umbrella and I am going again. So second day also there is no rain. So on the third day, I see a much stronger cloud, and also there is some uh, cold breeze. Uh, I am experiencing some cold breeze. So I um, again take umbrella and I am going. And on that day, I get a rain. So umbrella becomes useful to me. Then what happens? On the fourth day, when I go, uh, I see the cloud, which was similar to that of the first day. Then will I take umbrella or not? See, I will not take umbrella. Okay, that means I have a feeling that if only this much cloud cover is there, there is not going to be a rain. That is a feeling that is a gut feeling that I am getting. And AI is also like that. Okay, it is having something like a gut which can store some feeling other than strong data. That means other than hard data. We call that as weights. Okay, in the neural network context, we call that feeling as weight. And by adjusting the weights, a model will be predicting things. Okay, like I was predicting, I saw the cloud and there is no chance of rain. Likewise, AI will have some weights for each parameter it is having. It may be cloud, it may be breeze, it may be the morning temperature the day before, like that. Many parameter may be there, and it will have its own weight. If uh, you have to combine these weights and arrive at a decision whether I should take umbrella or not. It works like that. That means if like a mathematical model or statistical model, even statistical model, once the model is created, the parameters are fixed. Okay, you give the input parameter, you get the output value. That's the thing. And all other constants and all other functions will remain the same. But in AI, there is a post there is a possibility of changing this uh, constants and other values continuously, so that it adapts to the new phenomena, okay, or the extended phenomena. It automatically get adapted to the newest data sets. Okay, on a slightly different data also, it automatically it can get adapted to. That means it will change its perception. You may feel like that. You may take it that way. Like, so AI is basically trying to simulate a human thinking way in an algorithmic way, in a structured way. It is slightly, suppose when you took the decisions, you just imagine the previous situation. I got out of the house, and my previous day's picture is in my mind, how the cloud was. I may not be able to uh, numerically put it. That means 83.5% cloud was there. Like that, I may not be able to put it. But that picture is there inside my mind. From that picture, I have learned that today I should take this decision. Okay. AI also works in the same way. So it learns from data like our sensory perception. I use my skin for temperature. I use my eyes for vision, like that. AI also perceives these like data, like pictures, words, numbers, even numbers, to learn or to develop this gut feeling. Okay. Now, what are its abilities? Its abilities are highly versatile, and the most common one are language perception and recognize object. You know that AI cameras are being deployed in our traffic system, so it can actually it works on a principle in one category of AI called a computer vision. Okay, then it has problem solving capacity. Uh, like many capabilities are there for AI. Okay, if you take a everyday example, it help us in shopping. Uh, i- suppose if you have searched in Google regarding some one particular product like a pen, then within a short while in your all social media like Facebook or Instagram, you will be seeing advertisement corresponding to these, corresponding to the your search that you have made a while ago. So how does it happen? It all happens with the AI architecture working behind that. Okay. Also, you see chatbots in our uh, net banking applications and all other similar applications. And the rating system, surveying and learning consumer characteristics is one big area where AI works. That is, these are some real life applications. So let us be a little more specific. What are the principles engaged in AI? AI seeks to understand or model or replicate cognitive functions such as learning. Learning means how we are learning, uh, reasoning, perception, how do we perceive things, and solving capacity or problem solving ways, and language understanding using mathematical and computational structure. Okay, so basically this AI is nothing more than an algorithm, but it is an advanced algorithm structured in such a way that it can adapt to itself. Like I said earlier, it can change its own parameter and still generate the meaningful output. Now, what's the machine learning? Whenever you speak of AI, you also hear about machine learning. Actually, machine learning involves developing algorithms that allow a machine to learn from data. So AI is something like an umbrella term, and machine learning is the methodology that using which an AI technology is implemented. What are the key branches? One is neural networks, which is also known as deep learning. And another one is computer vision and natural language processing. Uh, then speech recognition is yet another one which I have not put here. And so let us have a small discussion on that. So what is neural network? See, a neural network is one type of algorithm where the model tries to imitate the function of human neurons. That is the inspiration from where neural networks started. That is the beginning of neural network. So scientists were trying to learn how human neural networks works and try to develop a mathematical algorithm which can simulate the similar functioning of in human network in mathematical way or in algorithmic ways, okay, or computational ways, I should say. So actually, these are the one which revolutionized the AI, or whatever AI you see now is the outcome of neural networks, I should say. And computer vision is also a neural network. Our computer vision is how computer sees things. Like our vision is how we think and we interpret things in our brain. Computer vision means how computer using a camera also, how does it see and it how does it extract information from what they see, what it see through a camera, and how store it, how to analyze it. That is computer vision. Actually, it is also a neural network. Usually, it is convolution category of neural networks called a convolution neural networks, CNN. It is called, and some modified networks also in computer vision 2, CV version 2 specification that is also coming. And another one is natural language processing. We all know that for a computer to understand something, we need to give a language which it can understand. But suppose if we have an option, if I speak to the computer in my own language, and if it can give, uh, if it can even develop an application and give, then that is fine, right? Uh, that means everyone becomes a programmer. So natural language processing means whatever language we speak to the computer in the form of text or speech, it absorbs, it analyze it and get information and convert it into a format which the computer can process. Okay, like running a search engine or anything like that. Okay. These are the three main branches of AI. Some other minor and specialized branches are also there. So before finding the application, we have to ask one question. One, and that is a disclaimer-free AI possible? Disclaimer-free means without condition. That means what I mean to ask is and is there any AI which can always give the true output or the best output? The answer should be no, because even though there are thousands of AI models there, you cannot pinpoint one particular AI and say that this is an AI which always perform 100% or 99.9% times accurately. That is not possible. So while using AI as a tool, we should not forget that it is not a replacement of human intelligence. It is never a replacement of human intelligence, but it is an assisting tool. Okay, it can do some task which we are not able to do, but it can never replace human intelligence, at least for the time being. Now, let us consider a system which is a forest ecosystem. Uh, Now I'm trying to say what are the processes involved in developing an AI model. Okay. Now in AI models, we usually follow a systems concept where one phenomena is divided into three components. One is input, second one is process, and the third one is output. I'm taking an example of a forest ecosystem where the inputs should be like solar energy, rainfall, nutrients from soil, carbon dioxide from the atmosphere, seed spores from surrounding area. These will be the input elements to the forest ecosystem. And what would be the processes? The process may include photosynthesis by plants, respiration by uh, plants, animals, and microbes, then nutrient cycling, water cycling, food web interactions, soil formation through weathering and organic matter accumulation. These are the processes that would be happening inside a forest ecosystem. Okay, these would be derivatives of the input. Okay, or it can be some values. Suppose if you parameterize it, will be will can have some values which can be derived from the input value. Okay, now what are the outputs? Outputs will be oxygen released to atmosphere and biomass, what we get by growing trees and all. Then organic matter added to soil, water vapor runoff to rivers or streams, and carbon storage in biomass. Likewise, these are the outputs. So all these constitute together on forest ecosystem. Okay, similarly, urban context, it may be having slightly different inputs, slightly different processes, slightly different outputs also. Okay. Now, how these are analogous to our AI system, or how it is fed into the AI system, AI model is created. These are like our inputs are like data. Inputs are represented in our AI system as data. Then we have AI models working, processing represents the processes. Okay, actually AI models try to duplicate the process or the simulate the processes which are involved. That means it takes input as data and it tries to uh, fit a model so that it can give the value, output values that represent the actual system output. Okay, that means oxygen released to atmosphere. If I take for an instance, this model should be capable of giving a numerical value corresponding to the that particular forest. Now, I just made this example to show the intensity, data intensity usually we see in AI model. Actually, in the early stages of artificial intelligence, people used to think that we can put any number of data into a neural network and we will get robust models. If the data intensity increases or the number of parameters increases, there is a chance that we can get better output. Actually, that is not the case. Now, if I split up these components, input components like solar energy, rainfall, soil nutrients, and the governing parameters, it will be a numerous number. For example, for solar energy, if you take solar radiation intensity, day length, canopy cover, leaf area index, such parameters will come. Then rainfall, annual precipitation values, rainfall intensity values, seasonal variability, or so many parameters may come. Other around 13 climatic variables will be influencing rainfall, which I have not put here. And also soil nutrients, you have some good number of parameters there. And carbon dioxide, you have another set of parameters. Then likewise, seed sports, you have another set of parameters. Okay. These are all the input parameters. Okay. Now, if you think in the classic context, how it is not always easy to model this, because multivariate analysis is kind of difficult thing uh, to manually do it. Okay, without the help of computers, it's not usually possible. But with the evolution of AI, to some extent, it was possible, and we were of the belief that we can put so many number of data and we will get a good output. That was the thinking in the beginning stages. Now, in previous slide, I just discussed the data about the input data only. And now, if you consider the processes, you may have to define these many processes. And when you should have indices or model to simulate all these processes. For example, photosynthesis is to be measured through leaf area index, or it can be measured through other parameters also, like respiration, many other factors affecting those nutrient respiration, and in nutrient cycling, you'll have to model another. Uh, you'll have to model and find another, or you have to fix a model for modeling all these components. Like water cycling, you will have to make another model. Food web interaction, another models. All these have to correlate, and you have to produce a meaningful output. So the processes that is to be modeled inside a larger system is always very huge number of processes. Actually, in our classic approach, we used to take any one particular phenomena like photosynthesis. We only try to fix a model for a leaf area index, or try to find out the leaf area index using GIS or whatever, or even manually, or by sampling, or whatever method you will try to model. That was the approach. Here in AI, we have an option to include all the process interactions. Okay. Okay. When output comes, we have a release or biomass or organic matter and water or runoff water. Okay. So we try to fix a model where it take data from input these data and try to make the gut feeling towards these many phenomena, and finally it gives an output that it is likely these are the values we are going to get in biomass. These may be the values, and oxygen release, this may be the values. Now, which AI model you have to adapt for a particular, that is one very difficult question. Now, it is a classic machine learning or ANN. Now, what is the difference between classic machine learning or ANN? Actually, machine learning is a kind of umbrella term, and ANN is only a branch of that. But ANN is used for deep learning, and machine learning is an umbrella term. Even it is machine learning is a superset which also contains ANN, we should say. But still, for our selection purpose, it should be treated differently. So this table gives some oversight when you have to use a classic approach or the conventional machine learning approach, like a support vector machine, or regression models, or random forest models, or you have to go for a deep learning, ANN deep learning process. The first one you have to consider is size of the data set. If you are having a small data set, you have to use a classical machine learning system. And if you have a moderate data set, or maybe the sampling point is 5,000 to 50,000, you can select between machine learning and ANN, depends on the complexity. And in a large set of data set, you should always go for ANN. Okay. Then for problem in type also influence the selection of the model. Uh, If if the complexity is low to moderate, you should go for machine learning, and a highly nonlinear model, you should always go for ANN. Then regarding data type, if it is time series data like hydrologic data, climate or ecosystem dynamics, if you are trying the model, you have to uh, use any ANN model like LSTM, that is long and short term memory model. Like that, any model you have to select suitable models. That is another choice. Which model you have to select is yet another. From which category you have to select, you can get an info from insight from this table. Okay. Then when you deal with the static tabular data, you can always go for machine learning. See, the main selection criteria is actually the abundance of data. Okay, if ANN needs a large chunk of data to perform well, that means it has a property called overfitting. Suppose the data is small, in sample points are very low, and this data may have extreme values. It may have noises, and ANN will be overfitting that. That means it will be trying to simulate. It will be capable of simulating even the noises. So when you do a testing, it will work fine. In the doing a validation, it will work fine. But when that model sees a strange data or the a foreign data is to that model, that output may not perform well. That means suppose you have created a model, a rainfall runoff model for a particular data set. You have it is working fine. When you test on the same data from a subset of the data, if you are testing that model, it might be working fine. But if you put some real case scenario, some other set of data into that model and predict the runoff, it may not perform well. That is a one issue with the ANN. So only adopt ANN if you have a large chunk of data. Now, this table, I'm not going to explain this table. This you may keep as a reference once you receive this PPT. It will help you select which type of ANN model is to be selected for particular typical application. These are a collection gathered from publications that is from published works. Okay, and the typical application I have limited to environmental problems. Okay, as I told earlier, the abundance of data will not increase the quality of the output, or it will not increase the quality of the model. Okay, so first we need to simplify the model. Now, how do we simplify the model? One is to start with the process understanding, not the data availability. That means usually what happens in academics is first they search for data, and if some data is available with somebody, you collect that, and you use that data without understanding the system and get a derivative model. At that time, we try to finish the work itself. But in real case scenario, that is not applicable. You need to thoroughly understand the process, and you have to decide what data has to come as input and which phenomena might be influential to the output, and accordingly you have to formulate your models. Then to remove redundant data, you can use correlation analysis, the classical correlation analysis. Then there is one technique called the feature selection. It is that technique itself is a machine learning technique where you are using some machine learning algorithm to select between or select features which are not relevant to the output. Okay, it has some technique called the wrapping technique. It can iteratively change the parameters which are used for a model, and it is checking. It is on computational application. You can just imagine. In background, you can sorry, in background, it is actually another AN. Now, reduce the time series using a lags carefully. You see, the time series data, that means data collected over a long period of time in constant intervals. These are called the time series data, and these data is actually it is a cumbersome to accommodate in the model. So you somehow convert that to lags by making cumulative values, or so there are some techniques you can find many literature on that. Then you can use the domain knowledge to collapse variables to integers. That means you can combine 2 or 3 variables to another index and use that index as an input or as an output variable also. That is also possible. That will reduce the number of vectors. Now, anyhow, you have to reduce too many outputs also. Suppose if you have to make model 2 or 3 or 4 or 5 outputs, try to use a proxy variable instead of that. That means a variable which can give a representation of all other contributing parameters. Like that, you can plan. If you have that, you will be able to do only if you have a system knowledge. Now, the conventional technique of principal component analysis can also be used. Then also data quality is yet another thing. You should not depend on quantity. Quantity was considered to be one big factor in the earlier days, but over the time we have come to the understanding that data quantity is not much of value even in artificial intelligence, but quality of data is of utmost importance. Then feature engineering I already told, and test the model. Once a model is created, it is tested. That means all the sensitivity analysis and all other aspects of modeling is equally applicable to AI models also. Only thing is that we may have some dedicated AI tools itself for testing the data. Okay. So let's take a practical case. Here I am trying to model a city or in terms of absorption capacity. Okay. And I consider only one factor, that is bio waste. So first thing is to understand how the bio waste is biomass. Bio waste mass is flowing inside an urban environment. Okay, here in an urban environment, usually there will be collection of bio waste, and it should be taken to some place, some centralized facility, and it should be treated there. But in Kerala context, it is slightly different. We may not have centralized facilities of huge capacity. Instead, we always use a decentralized approach. That means a small chunk of waste or households creating small chunk of waste will be managing those waste with using bins or any such household devices as a biocomposter or even bokashi buckets like that. Such devices are available, and they will be using those devices to process their bio waste. And where these facilities not there, that will be collected and it will be taken to a community facility, maybe a biogas facility or a windrow or some composting facility or any processing facility to be generic will be taken to such facilities. Okay. And there will be one small portion of bio waste which is thrown away to the environment also. Maybe illegal, but still it is being happened. What are the inputs that may come to the bio waste model? So one thing is waste supply, second one is environmental and climatic. Here, bio waste model, I mean to say that the biowaste generation up to the end point, that is up to the disposal point. That means there is a decomposition phase in between. Okay, when you model the bio waste in urban context, you have to take parameters of generation and the parameters that influence the augmentation or for a reduction of decomposition capacity, you have to model all such parameters, and then finally you have to arrive at an output, some index which can give some sense that this is the absorption capacity with respect to bio-waste in this particular city. Okay. So waste supply is one factor that may affect the capacity. Suppose if there is a system in a city, collect the 2 times bio waste from households. The quality of waste that is reaching in the processing center will be different. And if suppose there is a system where the waste is collected in the morning alone, that will be different. And if it is collected in the evening, that will still be different. So waste supply or waste collection and transportation is one important aspect. Then environment or climatic factors, temperature greatly affects the decomposition process, especially when it is an aerobic process or biological process. Then precipitation will add moisture to the biomass, and it will affect both ways. It depends whether it is moving away from optimum moisture content, it adversely affects. Sometimes it may reduce also. In that case, it will augment anyhow. Then humidity. Then consider into substrate or site-specific data, how that decomposition area is maintained or pile volume. For example, if you are using a windrow, even the height of the windrows are critical um, in the rate of decomposition of biowaste. And also porosity of the stockpile is another factor, because aeration is required. If the porosity is very less and the moisture is very high, also it will not allow proper oxygen supply, and it will affect. Then biological prior state. That means the baseline data of the environment is very important, critical also. Okay. If carbon dioxide CO2 flux is high, then there is low pace of decomposition. Then final one is the anthropogenic activities, that is the population density or nearby green fraction or the leachate assimilation option. These things, whatever man-made things are there, that will also affect the that data should also come as inputs. Okay, that affects the system. So naturally, data corresponding to these parameters should also come fed to the ANN model. So what are the processes here? The likely process is microbial decomposition. We know decomposition, and we have to define a parameter to quantify that. And here in this model, we have taken a kilogram of organic matter degraded per day. That is the indicator we have taken. Sorry, that is a parameter we have taken to represent the microbial decomposition. Now, similarly, moisture dynamics, oxygen availability or diffusion index. Also, on another factor is the pathogen attenuation that will affect the easy operation of the process. In that, if we have threat of pathogen attenuation, then we'll have to restrict our operations in open places like that. And leachate generation, it might take a health hazard. So these processes have to be monitored. Then finally, gas emissions. Where does gas emission from biological processes? Actually, even though aerobic composting, even though we say that it is aerobic, due to operational issues, some portion of the waste within the mass, within the stockpile, may not get sufficient aeration, and there is chance that there are anaerobic conditions arises. So there will definitely be a carbon dioxide and methane emission. Okay. So our goal is to minimize these emissions, these harmful emissions. And what are the outputs? Here we have to define, like I told you earlier, we can have many outputs representing good factors, like you can microbial decomposition rate can be taken as an output here. Decomposition is the process and the rate is the output that can be taken as one. But here there is one single parameter is taken as a net biodegradation capacity that is represented in as kilogram of organic matter degraded per day per hectare. Okay, it is a spatial aspect. It is usually used for modeling in GIs also. Okay. This is a continuous physically interpretable target. Why it is an interpretable target? I will explain in the next slide. Okay. Then how to measure this output? Suppose if you want a model, if you have created a model and if you want to use that model to some purpose, you have to make sure that the model is giving the right outputs, or it is reasonably accurate in predicting the output. Okay, so in order to check that, you have to measure some values and feed the data while training, and afterwards you have to keep on validating or feeding back the error in prediction back into the neural network like that. Okay. So here some measurement, physical measurement may be necessary for validating this thing. Some way of measuring it. Maybe carbon dioxide flux can be measured, or since you are measuring the decomposition rate, you can keep on continuously weighing files. Daily basis, if you weigh a stock file, what is the reduction in the mass? Likewise, you can model the output, sorry, find the output or measure the output. Okay. Now, here in this particular example, we have taken on composite indicator. It's a dimensionless number. It's scaled between 0 to 10. So the percentage load the site can assimilate without harmful output. That is the meaning of this indicator. Okay. That not explain the exact modeling scenario. So finally, in this particular case, we have developed one absorption capacity index, which is a dimensionless number, which can represent the assimilation capacity within a scale of 0 to 100. That means if it is 100, means it doesn't have any harmful effect. If it reduces from 100, it is having some overload. Right. So this is the model architecture. You can just forget for the time being. See, this model may not be applicable to applicable if you try to model some other cities. That may not be possible. For that case, you have to study that city particularly, because all cities are different actually. So many say actually as I told, while trying to reduce the number of inputs for future selection, the future selection stage, you will have to remove so many numbers of parameters or variables from the equation. So in that case, you may not be ending up with this kind of input. This is for one particular model. This may not be applicable for another one. And in output, I have shown 3 things, and that is also possible. Okay, in the previous slide, I have shown that I am using an indicator. Now I can modify that indicator some other scale also. Okay, using a single mathematical function, which is more understandable to operators or common people. Okay, here I have modified that to scale between 0 to 1. Okay, it is fractioned. Now, Now we have a model which represents our city, and I have modeled using the data collected from our city, and the model is predicting some output. Okay, now it is able to adjust itself if I feed more data. That is a main feature of AI model. So at any point of time, if I keep on adding the consequential data, it will be improving by itself. So it is always remains to be a useful tool. Now, how to use this for improving the output parameter? See, actually, our aim is to improve the environmental absorption capacity, or to maintain the absorption capacity in a particular level, so that that margin of absorption capacity is never depleted. Okay, we define a threshold, and for this case, the index, yet the absorption capacity index, what we define, I need to maintain it at 80%. That is my target, and I don't want to go for far below that. In that case, how to which input variable has to be alternated or changed to maintain that value. That but if I say the system that works in a summer season, or the absorption capacity that is available in a summer season will be different than from the rainy season. Okay, so during summer we may be fine. So when rain approaches, the system will change. In that case, our absorption capacity might reduce due to various reasons. In that case, we can have some system interpretation. If this much rain is coming, which parameter if I change, I'll be able to maintain the absorption capacity within available threshold. That system can be generated from here. For that purpose, we have a different model, that forecasting models, or some way of explanation will be there. Some of the terms may not be similar to everybody. So I'm not trying to explain this in detail, but it's possible that some we can derive some wisdom by changing some input variable, what will be the output. So it will help us to change that particular variable in such a way that actually, suppose if I want to change the emission of carbon dioxide and methane from a particular windrow plant, I can direct the operator to turn the windrow much more time. And you might be aware about the turn in the windrow. That means in a windrow, you have to mix it. You have to agitate it frequently so that aeration is happening. So if moisture increases due to rain, and if my model can predict that instead of turning it one time per day, if you turn it 2 times per day, you can substantially reduce the emission of methane and carbon dioxide. And how much is that reduction? Substantial is a qualitative word. Suppose if it can reduce by 20%, then that is a good take for me. So I will direct the windrow operator to turn it one more time per day. So that is possible inside this. I just put I was just putting an example for that. And it can give early warning alerts, monitoring learning, all these things. Whatever information we can derive from a prediction model, that can be done using this same model as well. Okay. Now these are the optimization approaches. These roles may not be familiar to everybody, but there are some rule-based techniques, like a greedy rule-based. That some techniques are available for optimization, from which we can predict what is going to happen. Okay, there are two types of optimization. In one, it's called a constrained optimization. That means which parameter is to be optimized, that we can explicitly tell to the model. That means you adjust the windrow turning frequency and give me the output. Okay, so and finally I have to be within my target. That is possible. Okay, and also another option is to find the let the AI model itself find the worst driver, whichever is causing the most problem, and that can be found, and what is the suggested uh, value of that variable, and they can suggest that value, and we can physically see that if achieving that value is possible or not. Then before using these information or directions or decision derived from this model, we have to check for uncertainty and safety using our uh, heuristics. That is our intellectual thinking. So without that system, proper system understanding, it is not advisable to use AI. So these are some interventions possible in urban context from this particular model. One is operational model, like I said, the increase turning frequency, forced aeration, like that. Then add a bulking agent to improve the porosity and the CNA ratio, or add inoculum to start the decomposition process. Like that, it can give some actionable intel. The model can give some actionable intel, or we can analyze the output and derive some actionable intel, which can be converted to the field level system to adjust and maintain the uh, index within that letter value or desired value. Now, in order to implement it, we need uh, some specialized tools. And if you want to create a AI model itself, you can simply do that in MATLAB. But if you want to implement it in a real life case, like from the data assimilation to information dissemination, then you need a large set of technical stack. So it doesn't mean that an AI modeler can learn and do all these things, but it is from different domain experts are necessary to achieve this level of compliance. Okay, and this I already explained, but without using numericals, but I'll have to skip for time. Okay, what are the challenges in adopting AI? It is having some problem. One is data privacy, and such concerns are there. And next one is algorithmic bias, because when you say we measure something, there is one thing inherent to it. That means if a measurement, a particular quantity is measured by two persons, you should give the same value. Okay. If I go and tape with a tape and measure some distance, 1 meter distance, I should get to 1 meter. And if another person comes with another tape and measure, you should also get to 1 meter. But if for the same data set, if you are using two different models, you will get two different outputs. So there is something called as algorithmic bias, and you have to wisely select. That's why I have put some 3 slides there in what situation which AI model has to be used. Now it lacks some transparency, and that is one issue. Continuous validation will also be prepared. So here I would like to give some idea about some research topics to your attention. Actually, the application of AI in environmental systems are in our Kerala context, which is very, very rare. Implementation of AI is seen very rare even in educational institutes. So it's actually I want to give to the academic people as a submission from the industry to come up and take up some studies in this regard, because the wisdom that we create from these models are huge, and the lack of models, reliable model, and lack of reliable information is actually driving our system in the wrong directions. And once you travel in a wrong direction for so long, then it may not be possible to return back because the system is too complicated. It is there are our administration system and the natural economical system, social system. These are all very complicated. Once you travel in the wrong direction for too long, it is not possible to come back. Okay, then you have to mitigate the issues. In that level, you have to go. So it is always a submission to the academia to come up with the early studies. Okay. And these topics I have put only from environmental engineering side, no other aspects are covered. And AI is not limited to environmental engineering for ecosystem design, not like that. It very everywhere that is there. Even from the microphone that I am using, I think there is AI inside built inside. So there's one, you can have some study on AI plus IoT for capacity prediction, then ecological carrying capacity modeling can be done. These are all very useful. These all would be very useful to decision makers. Okay. Then digital twins of ecosystem that doesn't exist at all. If you talk about digital twin, the availability of data will be one issue. Actually, from our side, the mission is trying to develop a broad spectrum MAS, can gather real-time data and feed the data, make the data available in public domain. So we are working in that direction. Hopefully, it will come up in a while. Then another area is wetland absorption. Then it can work in the direction of bioengineering strategies, pollution forecasting, environmental absorption simulations. I am not reading out everything. You can go through once you get this slide, and if you are interested, you can come up with any studies. That you already know that in remote sensing, AI has found even its place even before we start hearing about AI. Then oceanography studies, it's there. Reforestation and okay. Now, what is coming next? So before asking that question, let me ask another question. We all should have at least one laptop for everybody. Okay. Then how much of its processing capacity we are utilizing? I should say we will be utilizing less than 10% only. If I'm wrong. So some persons will be using that to the maximum. That is a different case, exceptional case. Actually, for the gadgets we have used, it is always underutilized. For ANN, sorry, not ANN, for AI is also like the same. We are not utilizing the full power of this one. What we utilize is like the readily made available. For example, ChatGPT you are using because it is user friendly. Okay, but I would suggest the academic people to avoid ChatGPT and go deep into the topic and come up with the models that is actually useful to the society. Then the next evolution of AI that we are going to see is artificial general intelligence. It is supposed to have cognitive abilities, and in a not so near, it is a distant prediction. The third generation will be artificial super intelligence that can even surpass human intelligence. That's our understanding. Okay. Now, if you have anything to discuss or question regarding this, now let me conclude by thanking you and thank you for listening to me. Thank you.
Thank you, sir. Now the session is open for discussion. Those who have doubts can Either ask or post in the chat box.
Participants can ask their questions or either put in the chat box.
Sir, I have a question. I have a doubt that you have shown for a simple problem, that is the real problem, that is the urban solid waste management, how to model it. And you have given a lot of input parameters. So is it necessary that these parameters can we take all the, is it necessary that all these parameters are to be considered, or it will vary depending upon the place, or depending upon the different conditions? Or we need, you as you said, or do we need to do a PC analysis or something to reduce these extent of this input matrix?
Actually, as I told, we should have a system understanding when we try to model any phenomena using AI. Okay, it is not only applicable to environmental engineering problems. It is applicable to any models. And also, increasing the number of parameters will not actually increase the quality of the model. See, what we see as the quality of the model, once you give a variation in the input, you should be able to predict the output after some time, or 5 days after, what should be the leaf area index, or sorry, or 5 months later, what should be the leaf area index. The model should be able to predict. And after 5 months, actually, if that leaf area and index we observe physically, then that is a good model. So in that context, we need not give all the input parameters. These may be influential parameter. The thing is that for the output, more than one parameter will be influencing the output in the same way. Okay. Suppose if you an influence curve, both curves will be looking the same. So one parameter becomes redundant. In that case, you have to remove that. So whichever parameter is capable of giving better output, that you have to identify. For identifying that, we have many techniques, and the system understanding one thing. See, actually, an AI model cannot be finished in one single modeling path. Once you have to model, and you have to again analysis the model, you have to verify the model, validate, and again you have to find the bottleneck. For that purpose, you can use some tools available, and also you have to use your wisdom. So without proper system understanding, it is better not to attempt AI. Okay.
Okay, sir. Thank you.
Any other questions?
Sir, actually, I have a doubt whether in regarding Kerala scenario, whether this AI model has been applied for any sorting of the waste collector, or regarding the AI segregation, or for any model has been developed. And the main
Yes,
main parameter may be the waste composition, or the type of waste, moisture content, whether it is necessary to input, or which platform programming is basically done in model developing. Because I've done a program for the erosion purpose, that's purpose in Python. So that was going accurately. So that's a doubt regarding the waste characterization, sir.
Yeah, okay. Regarding waste segregation and characterization, there had been 2 projects taken up by each mission, and there was one presentation, I think 2 days back, by Vinu. He was taking one project. He is from NVIDIA Technologies. and we are hand-holding that project. Actually, that is done in a different context, not related to soil and see, our requirement of segregation is of twofold. One is to separate between rigid waste and recyclable waste. Okay. That means this segregation is applicable to dry waste only, because using robotic systems, we cannot actually segregate between bio and non-bio. It's practically not feasible, even though theoretically that may be possible, but practically it is very difficult to create an arm which can pick bio waste from a mixed waste system. So what we have a play here is you have a mixed waste, a chunk of mixed waste. From that, you have to separate recyclables and characterize this. You have to sort it using different product. For example, if you are taking PET bottles, you have to, if you can identify Coca-Cola bottle and a Pepsi bottle separately, and put it in different sort it and keep it at different locations, put it into different bins. Then that is the best scenario we have. Why? Because you might be aware of EPR. Okay, it's called Extended Producer Responsibility. That means the producer of one product is the one who is responsible of disposing the end product. That is a sense of that. So if Coca-Cola bottles are being recycled, the Coca-Cola company is bound to pay for that portion. Okay. In that case, if you can identify, I have treated these many numbers of bottles, that amount can be claimed from Coca-Cola. It is done through a different framework. It is not that simple as I'm telling, but still that is the case. So the person operating that facility should be able to segregate between these, even brand wise. If you can segregate, that is better. So these sorting systems usually work on computer vision. As I think I mentioned that that is working on convolution neural networks. And now the computer vision version 2 is also in play. That is working on some modified and advanced neural networks. So actually using all these technology need an input, a training data. So in order to train, it will take some time, and that work is going on. Another work was in progress from CET also. Okay. Okay, and I'm not sure about I'm not aware about the work you have done about that soil erosion also. Maybe that's good work. Thank you.
Okay, thank you so much, sir. So, can we direct or involve the students in the project to start with the management of waste AI in combination with the LSGD or Sujitha mission project? In that way, is it possible so that some benefit from this FDP should reach the students too? Then it will be reaching the target, because that will be helpful.
Okay, I understand, ma'am. Actually, I should extremely welcome you in this regard. You can come to Sujitha Mission, or you can send your students to Sujitha Mission. And we also have one research support system, which we can finance up to 10 lakhs for a project. But it should not be a purely academic project. It should be have some developmental aspect which is beneficial to the waste management sector. If you can come up with such a proposal, Sujitha Mission can support up to 10 lakh rupees for a single project. And that may not be open to students. That proposal should come through the gate, through the principal. Okay. Of course,
Okay,
students
so
may be necessary to carry out the work, but proposal should come through the gate.
come through the mentor of the gate.
Yeah,
Right?
right. Yeah. Right.
So the form will be available with the Sujitha Mission so that we can have it.
There is no dedicated form, madam. You have to send a proposal, technical proposal, and you will be invited to the technical committee of Swiss Mission, and there you have to present. And we always look for the value in that project. Okay, if it is beneficial to our sector, we'll finance it.
So that involves the field target too, field collection, field segregation, like that, right? Along with AI.
Actually, it is not limited to AI. Actually, it is not limited to AI. Actually, we are looking for developmental project. For example, that sorting project using training of.
Because what's in mind is actually we will entrust the faculty and the students to move in this line along with this FDP, so that some contribution should develop from after an FTP happens. That's why I'm asking this. So I'll try my best so that we will come up with some idea soon.
Yeah.
And thank you for the very informative session, sir. Thank you so much.
Yeah. Also, please keep one thing in mind, madam. Actually, undergraduate students may not be suitable candidates for these projects because active involvement is necessary, and also the students will have to put some extra effort for learning the tools and techniques. Okay.
No, sir, we'll input the faculty itself, and
yeah, that should be fine. That should be fine.
Then we can move ahead. So we'll think of in such a way, sir.
Yeah, you are most welcome, ma'am.
Okay, sir. Thank you so much.
Participants can ask your questions if you have.
So there is a question in the chat box.
Yeah, I will read it out. The major problem ULBs are facing is misappropriation or mismanagement of funds due to non-awareness of results. What about making a digital twin of the waste management system of a ULB and predicting results of various scenarios? Okay. Actually, that is a very relevant question. But the pathway to digital twin is a little far away at the present time. That means if you want to establish a digital twin, we have to first establish a broad spectrum MIS, Management Information System. And the data flow has to be secured. And Swiss Mission has already started in direction. We are now taking up 2 projects. One is for developing a broad spectrum MIS, and another one is to develop a GIS tools for actually implementing the digital twin. And in a short while, we should be able to come up with the result. Actually, what in the chat box says, it is true that the decision makers never look at the information conveniently, or they are not informed well. That is one difficulty. And also, after deploying waste management systems, they are not monitored well also. That is also one system issue.
Any questions you can ask or directly type in the chat box. If there is no further questions, we can coordinate for a group photo session. So all of you, please switch on your cameras so that we can take a virtual photograph. Just a second. Okay, got it. So thank you all. So thank you, sir. Now Moving on to conclude, on behalf of the coordinators of this FDP and the participants gathered here, I would like to extend huge thanks to our speaker, Mr. Binod J, Assistant Executive Engineer LSGD, for his insightful and engaging address. Even though we are hearing the applications of AI in all these days, we are not completely capable of exploring its potential. But your session has been found very helpful in understanding the basics of AI and how it can be applied in real life practices. So it would definitely help the researchers as well as academicians who are working under AI. So your words have provided valuable knowledge and a fresh perspective that will carry forward. We are also grateful to the participants for making this event possible with your active participation. Thank you once again to our speaker and all the participants gathered here for your valuable time and coordination. Now you can fill up the feedback form given in the chat box and also in the WhatsApp chat. So once again, thank you all. Have a great day.
Thank you, ma'am. Thank you all.
Thank you, sir. Thank you all.